focus today is to sketch the parabola. Okay? Sketch the parabola given the general equation of the parabola. X raised to 2 minus 8x plus 8y plus 40 is equal to 0. Now you notice that the parabola that we have is in a general form. So what are we going to do? Remember that when we are talking of the parabola, those numbers or those variables that is being raised to the second power determines the kind of parabola that we have, whether it is a vertical parabola or horizontal parabola. Because so our variable that is being raised to the second power is the x variable, meaning to say the parabola faces the x-axis. The parabola faces the x-axis. So meaning to say the parabola that is considered in here is a vertical parabola. Now, how are we going to do this one? Now, in order for us to sketch this one, we are going to transform the parabola, the equation of the parabola into what? Into its standard form. That is the same as x minus h raised to the second power is equal to 4p multiplied by the quantity y minus k. It is because we do not know where is the opening of the parabola, then we might as well consider the other one. That is the same as the quantity x minus h raised to the second power is equal to negative 4p multiplied by the quantity y minus k. Notice that we have in here the two standard form of the parabola or the vertical parabola, which opens upward, that is positive, that is opens downward, and so that is negative. After recalling now the standard equation of the parabola, then we might as well transform this one into this form or this one. Okay? So let's try to get our parabola. That is the same as x raised to 2 minus 8x plus 8y plus 40 is equal to 0. What is the very first thing that you will be doing? Again, the variable that is raised to the second power, which is x raised to 2, including the variable that is the same as x, which is not raised to the second power, will be isolated at the left side. And the other variable, which is y, and the constant will be isolated at the right side. And so how do we do this one? And so that is the same as x raised to 2 minus 8x is equal to negative 8y minus 40. We will apply now in here the idea of completing the square. Okay? The idea of completing the square. So that you will notice in here, after making the transposition of the other variable and then the constant at the right side, notice in here that in the left side, that is within the x variable being raised to the second power. Now, this is the one that we are going to complete to apply this completing of the square. And so how is that? And so that is the same as we have now x raised to 2 minus 8x expected to be the middle term plus what would be the third term, so that we can have now the perfect trinomial square. So what would be the third term? The same as when we will be having the addition in here, now we might be also adding the same thing that we added in here at the right side. So that is the same as negative 8y minus 40 plus, that is blank. Now to get this one, to get this third term of the trinomial, that is, we are going to get the numerical coefficient of the middle term, that is the same as negative 8. And so divided by 2, that is the same as divided by 2, negative 8, divided by 2, and it will give you that is the same as negative 4. Now, negative 4 is being raised to the second power, and so that is the same as raised to 2, that will give you positive 16. If you added already the positive 16 in here, you have to add it also at the right side. So that is the same as plus 16. Now notice that we are making use of the completing of this square, so that our objective is to, when we factor this one into its binomial form, it will give you this form or this one. And so notice that we have already a trinomial x raised to 2 minus 8x plus 16. And that is a perfect trinomial square. Now what would be the factor of that one? So what would be the factor? Binomial factors. That is the same as x minus 4 multiplied by x minus 4. Notice that when we are going to multiply, it will give you this one. When we are going to multiply negative 4 multiplied by negative 4, that is the same as positive 16. Now multiplying this one, negative 4x, multiplying this one, negative 4x, so that if we will be adding them, it will give you negative, it will give you 8x. Now how about at the right side? Notice that this is the same as negative 40 plus 16. So addition of on right side, now it will give you now that is the same as negative 8y, negative 8y minus, that is the same as 24. Okay, 24. Now, what is our objective having using the completing of this square? Of course, we're going to bring out this form. Okay, bring out this form, and so it will give you now that is the same as, put them into its binomial square or the square of binomial according to the exponential laws of exponent. If they have the same base, copy the base and then add their exponent. And so we have now x minus 4 raised to the second power. How about this one? Factor out what is common. So what is common to them? Negative 8. What is left? Y. Okay, plus 3. Okay, y plus 3. Notice that we have already this form. As you can see, it will follow this standard equation of the parabola. So meaning, it will follow the quantity x minus h raised to the second power is equal to negative 4p multiplied by y minus k. Now, having said that they are the same, that's the time now we are now ready to extract. We are now ready to extract the vertex. Okay, the vertex of the parabola. Now, what is the vertex of the parabola? It will follow your point h and k. Okay, point h and k. And so, what must be our vertex? What must be our vertex? What must be the value of h? The value of h is positive 4. Okay, positive 4. Now, what must be the value of k? We have in here negative 3. And so notice that when we analyze the problem, now it will tell you already the kind of parabola that we have. Now, having this form, it will tell you that the parabola that we are going to consider is what? A vertical parabola opens downward. Okay. Now another one. Notice that after knowing the kind of parabola and then the opening, we already identified the vertex. The vertex that we have is 4 and negative 3. Now in here, we are now ready to sketch, but of course we have to look for the value, or shall we say, the measure of the latus rectum. Okay? Now what did we say about latus rectum? Latus rectum is always 4p. And that 4P is equated to the latus victum that you can see in the standard form, that is the same as negative. And so having said that one, our P now is negative 2. Meaning, if our P is negative 2, it only says that the opening of the parabola is downward, that when you try to use this negative 2, that is below the vertex of the parabola. And so let's try now to plot the parabola. Notice that in our parabola, the vertex we have in here is located in the fourth quadrant of the Cartesian plane. So I draw in here a fourth quadrant, only the fourth quadrant of the Cartesian plane. So 4 and negative 3 is located in here. Now, where is the P? Where is the P? That is count 2 units below the vertex. So that is negative 1, that is 2. Meaning to say, this must be the measure of our P. Now, that one now will tell you that this next point in here below the vertex is what we will now be focus. Okay? That is already the focus that we have. Notice that this is P, which is the same as 2. Okay? 2. The measure of this segment from the vertex to focus is 2 units. Okay? Now you might be saying, why is that 2? Why is that it is not negative? Because as I told you, the simple negative in here will just tell you that the opening of the parabola is downward. Okay? Now, having said that one, because you have already plotted the vertex and then the focus, you can now locate the endpoints of the latus victum. We know that the latus victum is, what's that? 4P. And half of the latus victum is what? 2P. Now, having this P as 2, that is the same as 2 multiplied by 2. Now, it will give you now that is the same as 4, which is the half of the latus victum. Using this one, 4 units count from the focus 4 units to the right. Okay? To locate the endpoint, one of the endpoint of the latus victum, and that is the same as 4 units. That is 1, 2, 3, and 4. So meaning the location of the latus victum is located at point 8 and 5. The same as at the other side of the latus victum, that is left side of the focus, count 4 units, that is 1, 2, 3, and 4. So meaning to say, the location of the endpoint of the latus victum is in here. Okay, so these are the location of the latus victum. Having drawn that one, that's the time we can draw now our parabola. Okay, having drawn the parabola, we can now draw the latus victum that connects the focal chord. Okay, so of course it will pass through the focus. So we have in here, so it will pass through the focus, and so this one now is our latus rectum. Okay, what is the measure of the latus rectum? That is the same as 2P. How about in here? Same. That is the same as 2P. So we have 2P. Notice that because we have already the latus rectum in here, we can also locate now the location of directrix. 2 units above the vertex. So where is that? That is the same as we have in here what is our directrix? Directrix is what? Y is located at negative negative 1. So that is our directrix. Y is equal to negative 1. Now, are we done? No, we are not yet done. Of course, we look into the labeling of our graph. And so, we have to label them. So, this is our vertex. Our vertex is 1, 4, and negative 3. What are the endpoints of the lattice with 2? That is the same as 8 and negative 5. So, 8 and negative 5. How about in here? That is the same as 0 and negative 5. And so these are the labeling of our points. How about our focus? Our focus is located at what? 4 and negative 5. 4 and negative 5. After having now the labeling of this one, of course, it is but proper also to name the parabola. What is the name of our parabola? That is the same as the quantity x minus 4 raised to the second power is equal to negative 8 multiplied by y plus 3. And so, that is the graph of the parabola. The name of our parabola, that is the same as the quantity x minus 4 raised to the second power minus is equal to negative 8 multiplied by the quantity y plus 3. Notice that our latus rectum can be seen in here, that is 8 units. That is the same as 0, 1, 2, 3, 4, 5, 6, 7, and 8. So 8 units. Again, our vertex is positive 4. So our vertex is positive 4. The h is positive 4. And of course, our y is negative 3. Notice that our p is negative. And so the focus is located below the vertex. And that is the graph of our parabola. That's the graph of our parabola.